Welcome to the Explainer. So if you're a developer, an architect, or honestly just anyone working in software, you know this pain. You've just finished writing this incredibly elegant, perfectly optimized piece of code. But now you actually have to document it. Ugh, right? There's literally nothing quite as tedious as manually dragging and dropping endless little boxes to build architecture diagrams just to explain that complex logic to your team. I mean, it takes hours, and let's be real, it's basically out of date the exact second you write a new line of code. It's just not fun. But what if your code editor could literally just read your logic and draw the whole shebang for you instantly and securely? Well, that's exactly what we're going to learn how to do today using local Phi models in Visual Studio Code.
Because look, this right here is the absolute biggest hurdle for modern developers. We all know AI is fantastic at analyzing code, right? But the massive glaring pain point is the privacy risk. You just can't send sensitive, proprietary enterprise code out to cloud-based LLMs. Your security team would absolutely lose their minds if they caught you copy-pasting the company's core logic into a random web browser. No way! But what if that AI lived entirely on your laptop? What if you could harness all that incredible analytical power without a single line of your code ever leaving your machine? That's the real game changer here.
Okay, let's dive right into this. Today, we have a highly structured roadmap for turning your raw code into visuals entirely on your local machine. We're going to hit the local AI advantage, verifying local models, connecting VS Code extensions, prompting for mermaid syntax, and finally, visualizing the diagram.
Starting off with Section 1, the local AI advantage, bringing Microsoft small language models to your hardware.
The absolute secret sauce here is something called small language models, or SLMs. You see, these are incredibly compact but still highly capable AI models. And Microsoft has really optimized this space lately with models like Phi 3.5 Mini and Phi 4. Because of their efficient footprint, they can run directly on your own local hardware, using runtimes like ONX or Llama. And this right here provides the perfect balance. You get the world-class diagramming capability of a modern AI, but, and this is absolutely crucial, because it's running locally, you guarantee that zero data ever leaves your machine. You completely bypass all those security nightmares of relying on web-based models.
So to actually pull this automation off, we're going to combine 4 core pillars to build out our local tech stack. First up, our AI models. We'll be using either Phi 3.5 Mini or Phi 4. Second, our local runners. This is the software that actually executes the AI, so think Llama or LM Studio. Third, we have our IDE bridge. These are the tools connecting the AI directly into our editor, specifically VS Code via the Continue extension or the Microsoft AI Toolkit. And finally, number 4, our output format, mermaid syntax, which is exactly how we'll get our actual visuals.
Moving on to Section 2, verifying local models, checking your runner environment.
Now, this is a vital check before you even think about touching your code editor. We need to make sure the AI actually lives on your machine. If you're using Llama as your local runner, well, it's incredibly simple. Step 1, just crack open your computer's terminal or command prompt. Step 2, type Llama list and hit enter. And step 3, just scan that printed directory that pops up for Phi 3.5 or Phi 4. If you see it sitting there, boom, you've successfully confirmed the download. Oh, and if you happen to be using LM Studio instead, you would simply open up the app and check your My Models or local folder directory to make sure your Phi model is hanging out there, ready to go.
Which brings us to Section 3, connecting VS Code extensions, bridging the local AI with your code editor.
Now, what's really interesting here is looking at the 2 completely distinct ways developers can hook up these local models. On one side, we have the insanely popular Continue extension. This basically acts as a bridge and uses a standard config.json file where you manually tell the extension, hey, here is where my local Phi model is running. Now, on the other side, we have the official Microsoft AI Toolkit. This one actually features a fully integrated model catalog right inside VS Code, allowing you to directly download and run these small language models via ONX. Honestly, both are fantastic options, but let's take a look at how to set up the most common method.
So if you're going the Continue extension route, here is your concrete step-by-step walkthrough. Step 1, jump into the VS Code Marketplace and install the Continue extension. Step 2, you're going to click the shiny new Continue icon that just appeared over in your left sidebar. Step 3, look for the little gear icon or settings menu to open up the config.json file right inside that panel. And finally, Step 4, you simply add your local Phi model to the models array inside that JSON file, just like that. You've linked the AI brain running over in your terminal directly into your code editor's sidebar.
All right, Section 4, prompting for mermaid syntax, highlighting code and executing the magic trick. Okay, but before we actually prompt the AI, we kind of need to know what to ask for, right?
Well, we're going to ask it for Mermaid's syntax. For anyone who might be new to this, Mermaid is this absolutely amazing JavaScript-based diagramming tool. It essentially treats your diagrams as code. It is incredibly good at translating structured text and complex code logic into beautiful, rendered visuals. Think architecture, flowcharts, or detailed sequence diagrams. It really is the absolute perfect structural output for our Phi models. Why? Because, quite frankly, AI understands text and code a million times better than it understands how to draw an actual picture on a canvas.
So the absolutely crucial point here is how we ask the model to do this. You highlight that giant block of complex code in your editor, open up your Continue sidebar, and you drop in this golden cheat code of a prompt. Let me read this exactly. Analyze this code and output a valid mermaid sequence diagram syntax using, quote, mermaid. Do not wrap it in extra conversational text. Just give me the code block. You see, the reason this specific prompt is so ridiculously powerful is that it forces the model to give you clean, instantly usable code. By explicitly forbidding it from wrapping the response in conversational fluff, stuff like, sure, here is your diagram, you prevent annoying errors when we actually go to render it. You are demanding pure, structurally sound mermaid syntax and nothing else.
And finally, Section 5, Visualizing the diagram, turning AI-generated markdown into beautiful architecture.
Because we use that precision prompt, the AI is going to spit out a perfectly clean code block. So, step 1, you just copy that mermaid code block generated by the Phi model. Step 2, create or open a standard markdown file, just a simple .md file, right there in VS Code, and paste that code inside. Step 3, open up VS Code's built-in Markdown preview. You can do this by hitting Ctrl-Shift-V on Windows or Command-Shift-V on Mac. And honestly, this brilliantly illustrates the true power of this entire workflow. Literally, the second you hit those keystrokes, your text instantly transforms into a fully rendered, beautifully structured sequence diagram. You literally just turned hundreds of lines of complex, asynchronous code into a crystal-clear visual map in a matter of seconds, all without ever leaving your editor.
Think about it. We've completely removed the friction of documentation here. Your highly proprietary logic stayed safely locked down on your machine, your diagrams were generated almost instantly, and you didn't have to manually drag a single box on a canvas. So I want to leave you with this question to ponder. With zero privacy risks and this exact kind of power sitting right at your fingertips, what else can local small language models automate in your daily workflow? Seriously, if they can understand your architecture this well, imagine what other tedious tasks in your next sprint they could completely conquer. Keep experimenting, keep building, and we'll see you in the next explainer.